Welcome to this explainer. Look, if you're running a print floor today, you already know how to get ink on a shirt, right? So today, we're skipping the basics. We are shifting our focus purely to profitability. We're diving deep into DTF scaling and margin control. You know, there's always this massive temptation to just go out and buy a faster machine, kind of thinking that raw print speed automatically equals higher profits. But the absolute truth of print operations, and this is backed by decades of observation, is actually fascinating. Garment decoration rarely lost margin at the printer. It lost it in finishing and material waste. Think about that for a second. The printer itself, it's usually doing its job just fine. Where your margin is actually bleeding out is in the silent, creeping costs of inefficient workflows, trashed film, and the physical labor required after the printhead stops moving. So, winning the profit game, it means looking away from the shiny new hardware and looking directly at your waste bins and your cutting tables. So let's talk about where that material waste actually begins. On one hand, printing isolated graphics straight down a continuous roll, it's basically paying to feed blank film directly into your trash can. Honestly, it's financially irresponsible. Every single square inch of that film has a hard cost attached to it. On the flip side, the strategic use of gang sheets maximizes your film real estate. The single most direct way to instantly bump up your margin is to make absolutely sure almost every inch of that film is covered in usable, sellable ink before it ever even leaves the machine. And to achieve that maximum density, we rely on gang sheet nesting. This isn't just dragging and dropping files at random, okay? You're basically playing high-stakes Tetris. You take one client's large chest graphics, and then right in the negative space around them, you nest another client's sleeve hits, or maybe a batch of neck labels for a totally different order. You build all of this into a single, highly dense, continuous layout using your RIP software. That software is literally the foundation of your margin control, because by packing the digital file as tightly as possible before you ever hit print, you take total control of your material costs right at the file preparation stage. Now, when you pack that film tightly, and you actually win at that game of digital Tetris, the financial impact of nesting hits your balance sheet immediately. First off, it drastically reduces your raw material waste. Like we just talked about, you're no longer paying for empty film to just ride through the oven. Second, it maximizes your ink utilization per square meter. You're getting the absolute highest possible yield out of your consumables. And when you scale this practice across hundreds of meters of film a week, the cost savings aren't just a nice little bonus, they are transformational. This simple shift in digital prep directly rescues margin that would have absolutely ended up in the dumpster. Okay, let's shift gears for just a second and look at our own shop floors. I want you to ask yourself this fundamental question. Where does your process actually slow down? I mean, if you want to scale your business, you have to pinpoint the exact spot where the work piles up. We just talked about maxing out the printer's output through digital nesting, but making the printer work harder doesn't mean a thing if the rest of the shop can't keep up with the printed rolls coming off the line. We need to find the true bottleneck. And the stark reality here is a massive mismatch. It's actually kind of ironic. Your commercial DTF machine is a highly advanced workhorse. It is perfectly capable of printing and curing a 100-meter roll of densely packed gang sheets virtually unattended. You just set it and it runs. But what happens when that roll finishes? It hits the finishing stage. Manually cutting those individual transfers out of that dense gang sheet, sorting them, staging the garments at the heat press, that takes intense physical labor. The advanced machine, not the bottleneck. The manual labor at the finishing table is the true bottleneck of your entire operation. So if finishing is the bottleneck, how are we increasing our actual units per hour output? Well, it's definitely not by printing faster. It's by optimizing the physical layout of the humans actually doing the work. Step one is to optimize your cutting station layout. You got to make sure operators have the exact right tools and plenty of table space. Step two is establishing an ergonomic staging area directly next to the heat press. The person running the press should literally never have to take 3 steps just to grab the next garment or the next transfer. It needs to be a seamless, fluid motion from start to finish. Eliminating that physical friction at the cutting and pressing stages is the actual real-world key to scaling your daily output. Now, this next truth from the source material really struck a chord when I was reading through it. Quote, "You cannot scale chaos." Just let that sink in. If every operator on your floor does things slightly differently, or if your files are prepped differently depending on who happens to be working that day, or if your heat presses are just wildly fluctuating in temperature, you are operating in chaos. And if you try to double your order volume while operating in chaos, you won't double your profits. You're just going to double your headaches, your misprints, and your waste. To actually scale, we have to pivot to rigid, unbending operational protocols. To eliminate that chaos, you've got to lock in your required technical baselines. We're talking strict 300 DPI pre-flight files, no exceptions. Perfectly matched ink chemistry, so you aren't out there mixing cheap ink with premium expectations. You have to control your shaker humidity, because environmental variables will wreck a print run faster than almost anything else. Throw in an exact 150 to 160 degrees Celsius heat press metric, and you completely eliminate operational guesswork. It just means simplified execution for your staff. When you strip away the variables, you strip away the errors. So why does rigid standardization matter so much to your bottom line? Because it transforms your shop from a reactive firefighting business into a predictable manufacturing line. And predictability is the absolute secret ingredient to growth. This level of standardization is exactly what helps shops scale profitably. By locking in your process, you ensure significantly reduced touchpoints, from the initial file prep all the way down to that final press. Fewer touchpoints literally means lower labor costs per shirt, and ultimately it guarantees improved consistency for every single client order, which drives the repeat business that sustains your long-term growth. Textile decoration only scales when it becomes predictable. Which brings us to our final thought for this explainer. I really want to leave you with this question to chew on. How predictable are the touchpoints on your shop floor today? Seriously, take a walk through your facility. Watch how many times a shirt is touched, moved, or adjusted. Watch how your operators are handling those gang sheets. If you see variation, if you see wasted movement, or if you see unprinted film hitting the trash can, well, you know exactly where your margin is hiding. Standardization, smart nesting, and optimizing that finishing bottleneck are your keys to unlocking it. Thanks so much for joining me on this deep dive into margin control. Now get out there and look at your shop floor with fresh eyes.